So these are the oh, yeah. Instrument typing, pressure, indicator, local mounted. Instrument function, one destination. Pressure indicator, local mounted, instrument typing.
Okay, question 13 on
Current pressure indicator,
what
local mounted.
I was talking about.
What? Question 13 on what?
Article 5300. Splices being. You can't have splices in county without a utility box. It's talking about the box.
Mhm.
Sounds like a sad.
Gary, is that you? Sounds like my dog farting. Where's Jay at? Which one are you on?
I don't remember. I haven't turned them all in yet, but I think I'm on 342.
One of the reasons I did it, but I'm not sure if that's good.
All right. Couple of you on Zoom.
Negative.
Log on to Zoom so I can show you guys a couple things before we head out to the lab. I wanted to go over the wash tank in the drill station today without actually bringing the trainers in here. But when you go to do these, I'll go over the operation with you, you and your partner. So you're going to need a partner to do wash tank and drill station faults. I haven't decided. I think drill station, I'll probably make those extra credit because they're pretty difficult. Well, some of them are difficult. But the ladder diagram is like 130 rungs long only. So if you've done the wash tank, you can see that you're going to be jumping around from rung to rung. Okay, this output is affected by this input. Okay, that output is like you're going to jump around. So on the drill station, it can be it can take a while to get to the right fault. But
How many faults are there?
on
The drill station.
There are 20. So
You get some kind of fix to this.
I want to make sure that you do the MT5 trainers, which by the way, there are now 5 sets. So this last one on the wall over here is available to get started if anybody wants to use it. Huh?
How do we get to the smoke again?
Just ask Jeff. Okay, yeah, so there's 4 on the wall, 4 mounted on the wall, and there's 1 in the back, 2 wash tanks, there's 2 drill stations. But I want to make sure you get through the MT5 trainers and the wash tanks for sure. The drill station is something you can use as a filler. And I'll make those extra credit. Okay, so let's take a look at the wash tank first. I don't know why I have a PDF with scribbles all over it, but so this is the wash tank, the outside of the trainer, and this picture right here is laying in the bottom of the cabinet. And this is handy because when you're in the cabinet troubleshooting, putting your meter on stuff, you're going to see, well, this is affected by LS1. So is LS1 closed? You need to know that. Well, you can look on this picture and see where LS1 is, right? And then when you open this thing up, this is what you see. So a couple important things to think about. You're going to have this terminal strip over here on the right-hand side that's going to have a lot of the wire numbers that you need to troubleshoot. But if you look at the ladder diagram, let's say I wanted to check to see why solenoid 3 is not coming on. So here's solenoid 3, right here. So I need to check wire 10A. So at the solenoid, where can I check wire 10A? After the fuse, but I'll go back a second. Remember I told you the whole output back thing?
Oh, over there.
Here's the thing that I want you guys to do. And I'm seeing you guys troubleshoot in a couple different ways, and that's fine. It's really whatever's most comfortable for you. But yeah, but where am I putting my meter leads? So here's 1 meter lead. What wire number is that? 2. I want you guys to get in the habit of checking everything to 2. So on this rung, as it stands, what voltage should you have right here? Zero. Because the latching relay normally open contact is open. The cylinder return normally open push button is open. If I look in that cabinet though, and it's in its faulted state, so I'm saying the latching relay is pulled in. You can see that looking in the cabinet. That means this should be closed. TR4 is de-energized. It's normally closed, so that's closed. You should have 120 volts at the solenoid right now, right? So one hint is this white light on? But whether or not it is, I still want you to practice this output back thing, and I want you to check everything to 2. If it's more comfortable for you to check across a component to see if there's a difference of potential, that's fine. Some people have trouble getting their head wrapped around that. I'm one of those people because I don't like to think, okay, is this on or is this off? So there should be a difference of potential there. It shouldn't be. But if I check everything to 2 and I know at this point this entire rung should have current flowing through it, that means everything on the load side of the load should have 120 volts difference of potential to wire number 2. So if I'm doing output back, I'm going to check here, and then I'm going to check here. And if I'm getting 0 on everything, I'm going to keep going there, there, there. What if all of a sudden at the latching relay on the load side, so wire number 9 on the latching relay in the cabinet. So in the cabinet, the latching relay is right here. So I'm checking on the latching relay itself, wire number 9 to 2. So I have my red lead on wire 9 on the latching relay normally open, and my black lead on a wire number 2. I could get that 2 from anywhere as long as that wire number 2 is good. Is there going to be a 2 on the latching relay? Yeah, there is, because the coil right here is going to have a 2 on it. Where was I? There. So if I have 0 in all these places, 0, 0, 0, 0, 0, and all of a sudden I get 120 volts right here, what is the problem? Wire number 9 on rung 20 is broken. Okay?
Just from being Jay doing that the other day, there was a few times where we were having like weird voltages pop up, like 50 volts or something like that. So then you go, that's in the main panel, then you go to the sub panels, turn those switches and get a different ones.
Okay, yeah, and that's a good point. So wire 10A, if I want to check wire 10A, or even I'm doing this fault, where am I checking solenoid 3? Wire 10A. Yeah, on the trainer, and on this terminal strip, there are some fuses. I think these are them down here. So there is a fuse there, fuse 19. And there should be on the load side of it, wire 10A. So 10A goes from that fuse out into the field. And on the trainer itself, underneath the process, I got red scribbled all over it for some reason, but this junction box number 1 down here, that has all of the wiring going out to the field components, I guess you'd call them. So all these solenoids, all the limit switches. If I wanted to check wire 10A, in real life, I'd have to check it at solenoid 3, right? But in here, I can check it in the junction box. That's what that's there for, so we don't have to keep taking shit apart and put it back together. So on the ladder diagram, I'm checking wire 10A to 2 in that junction box. And then I'm going to the fuse in the panel and checking 10A to 2. Then I'm going to TR4, that's in the panel, latching relay, and so on and so forth. So that's, remember, that's output back. What if, in that same scenario, the latching relay is not pulled in?
You can manually toggle.
Yes, but I don't want you to do that. Huh? Yeah, I mean, if solenoid, solenoid 3, we need that to energize. Maybe we need the cylinder to return for the fault to go away. But you can see on there that the latching relay is not pulled in. So, of course, the solenoid's not going to energize until you energize the latching relay coil. So then you're jumping down to rung 25. The latching relay is not energized. Well, let's say CR8 is pulled in. You can look at it. So that means that this CR8 normally closed contact is open. So then you have to go down to CR8 and see why that's still energized. Well, maybe LS1 is normally closed, but for some reason you're not getting voltage there. Maybe that's your problem, right? So you can see how you can be jumping around in different rungs. The drill station, doing that on this ladder diagram is interesting, but I would recommend you do wash tank first, because it's really, the ladder diagrams are set up pretty similarly. With the descriptions on the right of what's going on. You remember what the numbers on the right mean?
Is that where it appears elsewhere as well? What contacts the coil controls?
Yeah, so for those outputs, so CR1, CR1A, CR1B, you're gonna see contacts for those coils on all these different rungs. Why is rung number 12 underlined?
Is that where the coil is?
It's normally closed. Look down at rung number 12. See, CR1 is normally closed. So that's what all those numbers mean. To help simplify this, if you read through the right-hand side, the descriptions, you have air solenoid, auto, manual, cycle select, and you'll understand what these mean when you run through the process on the, there's a piece of paper above the push buttons that shows you what each process, how you should do it. But I wanted to bring you to right here. If you take a look at rungs 62 through 72, so get that mental picture in your head, and then I'm just going to scroll down. Looks pretty similar to this rung 73 through 85, right? So when you break, what I'm saying is it's a lot of rungs, but if you break this down, let's see if I can draw it on here.
So like that.
All this is drill number 1. Okay. I hate this thing. All this is drill number 2. All this is drill number 3. All this is drill number 4. And then there's some other stuff down here for the coolant, which is the last part of the cycle when you run through it. So once you get that kind of stuck in your craw, that there's several rungs for each drill. So let's say drill number 3 is not going when it's supposed to during the process. Well, I'm probably starting on these rungs right here, right? Because this is all drill number 3 shit. So you can break it down into that simplified process. And it makes things look a lot more manageable. What else? Okay. Last thing. Fucking thing. So we're looking at drill number 3 right now. What does that dashed line in the middle mean? It's a mechanical connection. So This you're gonna need for sure. Some of you might get there on your own. Maybe, maybe not. What do I need to happen for drill number 3 to start? Basically what happens in the process is it simulates like a part drill or part whatever. So there's a part on the table, the platform extends, the clamp comes down onto the part, and then you got 4 drills doing different things at different times depending on which cycle select you're in. So you have a fault that says drill number 3 is not going, it's not extending. So where would you start? Here, this is the entire process for drill number 3. CR30, why? Awesome. Drill number 3 is going to be controlled by these solenoids, right? It's not going to extend, and the motor itself is not going to turn on without CR30 closing. See that? So CR30 is really kind of the mother relay for drill number 3. If that's output back, then I can start on wire number 156 and check that to 2. Then I can check here to 2, here to 2, here to 2, here to 2. Now, this is where things can get confusing if you don't understand that that auto off cycle button. See where the arrow is right now? What's it pointing to? Off. So neither of these plungers are touching the contacts of their rung, right? If I'm in auto, which set of contacts is it going to make?
153, 154.
Right.
169 and 154. Because the asterisk is on the left-hand side, see the little asterisk here? Auto's on the left, so that means if that switch is in the auto position, that means this is going to be made. And most of your faults, you're going to be in the auto mode. So what I'm trying to tell you is the current path for this, if you're in auto, is going to be like this. And then you could have different options here, right? So just keep that in mind. You have to understand this auto off cycle push button in the current path. A lot of people will start troubleshooting this and then they'll just keep going this way. Well, if you're in auto, you're going the wrong way, right? And that's the same for all the other drills. So drill number 2, set up the exact same way. This CR28, that's kind of like the mother control relay for drill number 2. If you're in auto, you're gonna have to follow that same current path, right? Okay. So everybody should have plenty to be working on. Next week, I'm gonna get into the math of the conduit bending. And you'll have some conduit bending labs to do, but I really want you to concentrate on, don't do conduit bending labs unless you've got all the troubleshooting labs done, except for drill station. Drill station is going to be extra credit. Okie doke. All right.
Did you just say inseminate?